Hi, my name is Kent Lee and I teach computer science at Luther College. In this series of videos, I'll be talking about data structures and algorithms with Python, which goes along with the text that I've written with my co-author Steve Hubbard. I would highly encourage you to go out and get this textbook and read it along with watching these videos to get the most from these topics. Okay, so I'm going to assume that you have had some introductory programming already in Python. If you have not, you can watch my introductory videos on YouTube to get up to speed. And I am going to assume that you've seen a little bit of object-oriented programming but haven't done a lot yet. So I want to take some time here and go through some object-oriented programming with you to make sure that you understand about the different parts of an object-oriented program and how they work together. To motivate our discussion, I'm going to develop a program that dumps a file, the contents of a file in binary, actually prints it in hexadecimal to the screen. To get started with that, I actually want to be able to look at ASCII characters within that hexadecimal file. And so I thought I would take just a moment here and we would look at ASCII and understand exactly what ASCII is. Every character in the computer, so for example the character A, is actually represented by ASCII codes in the computer. So if I were to say something like x equals A here, I can see what its ASCII character code is by doing the ORD of that value. So the ASCII code for the character A is 97. It's easy enough to look these up on the web. If I bring up a web browser here and search for ASCII table, it'll work just fine, and we go out and take a look at it. We can see here's a copy of the ASCII table, and if I go down and look at 97 as a character, it's the character A there. So all these ASCII codes are out there. Many of them are printable, some of them are not. Some of the early ones here at the low numbers are some of the control characters for old terminals. Backspace is one of them. End of text is another one. Carriage return and line feed. Carriage return is line feed, I guess, is 10. Carriage return is 13. So we can actually look at those as well, even though they're not printable characters. If I say something like y equals CHR of 13, and then I go to print y, you can see that I am printing what looks like nothing here, but I'm actually printing that carriage return. If I look at it there, I see a \r, which is the representation in Python of a carriage return. If I were to do something like z equals CHR of 10 and then look at z, that's a new line, and when I print z, you can see I get an extra line where when I printed y with the carriage return I didn't get an extra line. When I printed z I did. That's because \n actually makes the cursor go down to a new line, and then the print does too, so I get two blank lines here. So there are printable and unprintable ASCII characters, but in my hex dump application I would like unprintable characters to print as just a dot when they're printed to the screen. I just like a period printed to the screen whenever it's an unprintable character that I'm trying to look at. So that kind of motivates me to customize the behavior of printing ASCII characters, and to do that, that means that I want to create a type. And that's what object-oriented programming is all about. It's about creating our own types. We do this for two purposes. One purpose in object-oriented programming is just to group our code and our data together, because code and data kind of go hand in hand a lot of times. The code we write is manipulating some type of data. But more importantly, writing our own types lets us customize software that's already been written. So we are able to sometimes take advantage of software that's been written by writing our own classes that can be used by this previously written software. I'll try to demonstrate here for you in just a moment. So we'll keep this ASCII table kind of in the background there. I know you can't see all of it, that's alright. And we're going to start up Wing. And I'm going to start to develop a new type here. A new class is what we call it in object-oriented programming lingo. So class or type is really the same thing. And so I'm going to write a class here, and the class is going to be class ASCII. Okay. So what I want to do eventually is I want to be able to create a main program that's going to read a file. It's going to be a hex dump application. But as I'm going through this, I want to I'm going to set up some test code for myself to begin with. So I'm going to create an ASCII character. Let's just create a couple of these ASCII characters. Let's say that we create x is equal to ASCII, and then we'll put in a 97, which we know is A. So we're going to pass that in, and then we're going to do a y equals ASCII 3. Okay, z equals ASCII 10. So we're creating 3 ASCII characters here, one of them which is printable, the A, but the other 2 are not. To be able to create a value, this is much like we do in Python. So if I were to say something like lst equals list, I'd get an empty list. We saw that earlier, that we could create an empty list that way. I'm kind of doing the same thing. This is a type now. ASCII is a type, and I'm passing in a value to it, 97, which is the ASCII code for it. And so I'm creating an object there, just like I was creating an object, an empty list object here. Okay, so to do that, I have to create what's called a constructor. Okay, so the constructor is what allows me to say the name of the type and pass in a value to it. And in Python, that constructor is called def underscore underscore init underscore underscore. And we're going to have the ASCII value passed in. So there's 2 parameters that get passed to this init. Self, which is the object itself, and ASCII val, which is this value that I'm passing right down here. Now you say, well, I'm only passing 1 value in, but I have 2 declared. This is part of the constructor. Python creates the object and passes the object in as self, so that we can initialize the object. So when we want to put something in the object, we'll write self dot. When we want to reference something in the object, self is a reference, like we talked about earlier, about references and objects. Self is a reference to the object. And if I write self dot, I'm going into the object, and in this case, putting something in the object. So we'll say self dot val equals that ASCII val in this case. Okay, so I've stored that value in the object, and with what I have here now, I'd be able to do some things with this object. So for example, I could print x. I'll try printing y here, and I'll try printing z as well. To call this code, to be able to actually execute it, I'm going to write if underscore underscore name underscore underscore equals underscore underscore main underscore underscore. The advantage of calling main this way is that if this module were to be imported into another module eventually, then this code, this main, would not run. This is a test program for this module, and if I run this module as it's on its own, then I'll run its test program. But if I import this module into another module, I won't run the test program, which is a nice feature of Python, to be able to write your test code right within your module and then be able to later import it into a different module. So if I go to run this, I'm going to run it with no arguments. I'm going to save this file, and I'm going to put it in my actually in my data structures folder, and I'm going to call it hex dump because that's what it's eventually going to be. And when I run it, I should be able to go and look at the debug IO and take a look and see what the output looks like. And this is what I get right now. Okay, so now we actually get to see the references as they're printed. So these are 3 references that are being printed because I'm printing X, Y, and Z. So the reason the references are being printed is because right now the code doesn't know how to print an ASCII value, how an ASCII value is converted to a string. So if I want to customize this behavior of print, I can add some more code to the ASCII class here to tell the print function how to convert, actually any function, how to convert an ASCII value to a string. So that's done through what's called a magic method. So this method will get called automatically if it exists. If it doesn't exist, it's just going to print the reference to the object. But if it does exist, then I will go ahead and have some control about how it's converted into a string. Okay, so I got to go back here and look at my ASCII values and see, well, what are the printable characters? And really, the printable characters kind of start at 33 here. These are all printable characters through all of those, down to 95. Those are all printable characters. 96, all the way down through, it looks like 126 are all printable characters. And then beyond that. So anywhere between 33 and 126. So I'm going to ask if self.val is greater than or equal to 33 and self.val is less than or equal to 126, and if it is, then what I'm going to return is the CHR of self.val. The CHR will give me the printable character as a string, so I'll return that. Otherwise, I'm going to return just a period to be printed. So now when I go to run this, there's what gets printed, A, period, and period. So the other two, not printable, they'll print as periods, and A will print as another value. Now I'm going to add just a little bit more to this. Okay, so I'm going to put these 3 things in a list. So I'm going to create a list here, and that list is going to contain X and Y and Z. Put those 3 references in a list here, and then I'm going to go ahead and print that list. Now I don't want to have to do this each time, so I'm going to turn that off, and I'm going to tell it to autosave when I go to run it. Okay, so I got that nice behavior for printing, but when I put them in a list and try to print them, I'm back to the references again, and that's because there's another magic method called repr that is another way to customize the behavior of Python. So repr is kind of like string. It's supposed to return a representation of the object, and generally what we want is for it to return a representation that, if executed, as code would give me the value. So I'm in my repr, I'm going to not care about whether it's printable or not, and I'm going to return a string. The string that I'm going to return is ASCII left parent plus self dot the string of self dot val plus a right parent. Okay, so if I go back and run this again, there's what I get, a dot dot, and then if it's in a list, I get ASCII 97, ASCII 3, and ASCII 10. So this is exactly what I want to see. So then a lot of the code that you're going to look at, you're going to see in this series of videos, you're going to see string and you're going to see repr both implemented for classes. Now I want to make sure that you understand this code well, so in the next video we're going to actually use the debugger to step through this code and see how it works exactly.